Okay, so you've balanced chemical reactions before, and for a lot of contexts, you're probably just fine at that. But there are some new tricks involved when you have to balance a redox reaction, because not only must you balance all of the atoms that you can see in there, you also have to balance the number of electrons that are being transferred. The electrons are going on behind the scenes, but they have to be right. You have to be able to explain how much charge went up and how much charge went down, and there's a special procedure for doing those. So let's see how that works. They've given us a list of steps here, which I'm going to go through, and we'll see if we can balance this thing. So, step one, it says, split the given unbalanced equation into two half reactions. Okay, well, ignoring oxygen and hydrogen, you have to look at what else is in your reaction. And in this case, pretty clearly, we have one story going on that's about zinc, which got oxidized, it looks like, and another story going on involving nitrogen. So we're going to pull this reaction apart into one line that's about just the zinc, another that's just about the nitrogen, and then we'll balance them independently. So we have Zn, leave some space, arrow, and Zn2, and then we have NO3, and then N2O. Okay. Add mole coefficients if necessary to balance the non-hydrogen, non-oxygen atoms in each half reaction. So this reaction is just about zinc, and just counting atoms, we have one here, no need to change anything. In this case, though, ignore the oxygen for now. If you just look at the nitrogen, we have one here and two on the right, so that's no good. To fix it, we put a coefficient of 2 on the nitrate. Okay, so all we're balancing right now is the N's, and now that's done. Next, balance oxygen atoms, if necessary, by adding water to the side with less oxygen. Well, this first reaction's easy. We have no oxygen on the left, none on the right, so that's beautifully balanced. Nothing to be fixed there. Second reaction, we have not 3, but 6 oxygen on the left, and only 1 on the right. So to even this up, if we have 6 here, 1 here, we need another 5 oxygen on the right. And the way that you deal with that is you add 5 water. We're stuck using chemicals that are available in our solution. In this case, they say this is happening in an acidic solution. So you've got all the water molecules you need. If you need oxygen, this is a plentiful supply of it. So, okay, now we have, for oxygen, we're 0 to 0 and 6 to 6, so that's all balanced out. What's next? Balance the hydrogen atoms in each half reaction, if necessary, by adding hydrogen ions to the side with the less hydrogen. Zinc doesn't have any hydrogen on either side, so that one's good. Hydrogen, or this line, 10 hydrogen on the right, none on the left, so this side needs hydrogen. You can't just add H2 or anything like that. You must add H plus ions. Why? Because they said we're in an acidic solution, and there's plenty of these in an acidic solution. Okay, so that takes care of our hydrogen problem. We're now, oops, I'm sorry, I can't just say H, I have to say 10H. 10 hydrogen ions. Good. Okay, now we have 10 to 10 for hydrogen, and that's all balanced out. Next, balance the charge by adding electrons to the reactant or product side of each half reaction. Electrons have a negative charge, so if you're balancing charge, electrons can only drag you down because they're negative. So what you're doing here is you're looking for the higher side, and you're adding electrons to drag it down to match the lower side. The charges on zinc are 0 on the left, 2 on the right. So if you add 2 electrons over here, that's now balanced. We have 0 charge on the left, and on the right our charge is 2 plus negative 2, total of 0. Now the tricky one. Well, this side's not bad. On the right side of our nitrogen reaction, we have 0 plus 0 is 0. Neither of these has any charge on it. On the left side, 2 nitrates minus 1 each, that's a total charge of minus 2. 10 hydrogens, that's a total charge of plus 10. Negative 2 plus 10 means our total charge is 8 on the left side. So if we're going to balance charge, I'm going to move this a little bit to make room. We want to drag down the higher side. We're going to add 8 electrons on the left side. And now our charge is balanced. Total charge of 0 on the left and 0 on the right. They don't have to add up to 0, but they have to add up to the same amount. So that was balancing the charge, step 5. That's all good. Now, we want to add these together, but we can't right now because the number of electrons must match, and it doesn't. This reaction is only talking about releasing 2 electrons, but this is talking about taking 8. We have to equalize those numbers. To do that, we need to get this up to 8, which means we're going to quadruple this entire reaction. We're going to multiply the whole thing by 4. 4 times as much, 4 times as much, 4 times as much. Now that we have matching electrons, we can sum these to get a total reaction, and that will be 4 zinc plus 2 nitrates. We're adding up the entire left-hand side. And I'm not going to put in the electrons because they are the same on both sides and they're going to cancel out. Now that we've used them to match up the reactions, we throw them out. So our entire left side is 4 zinc, 2 nitrate, 10 hydrogen. Our entire right side is 4 zinc, 2 ions. You don't have to say zinc 2, it's the only kind as far as I know. Dinitrogen oxide, and I'm sorry, not N2O, H2O. And that's done. Let's try another one, see if we can remember all the steps. So step 1 is split it up into 2 reactions. We have one story here that's about manganese, and another story that's about iron. So MnO4 minus, arrow, Mn, iron 2, iron 3, and away we go. First, balance everything that isn't oxygen or hydrogen. So 1 manganese, that's good. 1 iron, that's good too. Next we do oxygen. This side has 4 oxygen on it. This side doesn't have any, so we must add some oxygen. 4 to be precise. Four oxygen on the left, 4 on the right, and there we're done. Remember, you can't just add oxygen as much as we would like to. You have to add water because we're in an aqueous solution. So that takes care of our oxygen problem. Next is hydrogen. This iron reaction is fine for hydrogen. It's 0 to 0. But in this one, we just created a hydrogen problem. We have 8 hydrogen on the right. We need 8 on the left. So there's that solved. Next is charge. We add electrons to balance out the charges. The total charge on the left of this reaction is negative 1 plus 8 plus 7. The total charge on the right is plus 2. So this is the higher side. We're going to drag it down by adding 5 electrons to it. For the iron, the total charges are 2 and 3, so we're going to add an electron to the higher side to drag that down. Now we have 2 charge on the left, and 3 plus negative 1 is 2 on the right. And now that these reactions are both done, they're both balanced, we can add them together, right? It's a trap. Don't say yes. What do we have to do before we add these together? The number of electrons has to be matched up. Right now, this reaction is saying, give me 5 electrons, and this reaction is saying, okay, I'll give you 1 electron. That's not going to fly. But we can take this second reaction and say, okay, we need both of you to be 5, so we're going to do 5 times as much iron there, 5 times as much iron there, and that'll mean 5 times as many electrons there. Now we can add them together. It's like a financial transaction. You can't say I'll give you I'll give you $1 and you'll get $5 out of that. That doesn't add up. The transaction amounts have to be the same. It's got to be I'm giving you 5, you're gaining 5 because it's these are really the same electrons. We're just seeing them from two different perspectives, so those numbers better match. So reaction here would be MnO4, and we get 8 hydrogen. That's from the acid, and 5 iron 2s. Manganese 2 plus 4 water plus 5 iron 3. Okay, and that should be done. When you've written one of these, you can go through and check and make sure that every single thing matches up if you want to make sure that you've done it correctly. If we count atoms first, we can say manganese, 1, 1, oxygen, 4, 4, hydrogen, 8, 4 times 2 is 8, iron, 5, and 5. Total charge, -1 plus 8 plus 10 adds up to 17. And on the right, 2 plus 0 plus 5 times 3 is 15. Total is 17 again. So if all of those things match, then you probably did it right.